Now, unit of torque is Newton meter and is not written as joule. Now, if you'll see the unit joule is a unit for work. Okay, so work is force into displacement. So force is again in Newton, and displacement will be in meter. So this should be Newton meter. And in honor of a scientist, joule, they call it as uh, they use the unit joule. However, that is not the case with torque. In the case of torque, though it is same Newton meter, we mention it as Newton meter. Okay, we don't write it as joule. And the reason being that torque is a vector quantity while work and energy is a scalar quantity. Okay. So vector quantity is one that depends on both magnitude, that is the strength, and direction. Okay, so it depends on two things, magnitude and direction, whereas scalar, it only depends on magnitude. Since work is a scalar quantity, it has been mentioned as joule, whereas torque is a vector quantity, hence it is written as Newton meter. Now just to clarify something on vectors and scalars. So vector, for example, force is a vector. Now in order to give a specification for a force, okay, so suppose this is a door or the opening where you have to push this box. Okay, so assume this to be a box over here and you are pushing it. So it will require 10 Newton of force. Now the direction is very important. If you apply a force of 10 Newton in this direction, will this box go inside this? No, it won't. This direction it won't. So you have to be, it has to push in this direction so that it goes through this. Hence direction is very important. Scalar, for example, temperature. Say I have a body temperature of 38 degrees Celsius. Now it doesn't matter which direction I'm standing or which direction I'm measuring. Okay, it is 38 degrees Celsius, that is enough, that is all the information that is needed. But in case of force, you need to specify where you are applying, okay, in which direction you are applying. Okay. Hence vector quantity are something in which you have to determine direction as well. So torque is a vector quantity, hence we write it as Newton meter. Okay, motion or direction of a body. Okay. So there are two motions. Okay, so if a body is pivoted and you apply a force, okay, it will be two kinds of motion. It will be a clockwise motion or a anti-clockwise motion. So clockwise motion will generate a clockwise torque or clockwise moment. So motion of a body in a clockwise direction will produce a clockwise torque. Okay. And a motion of a body in an anti-clockwise will generate an anti-clockwise torque, or a body will move in an anti-clockwise direction. So suppose there is something over here, okay, this has been pivoted over here, and if you hit it in this direction, in that case the body will move in a clockwise direction, and if the same body, if you apply a force from this side, it will move in an anti-clockwise direction. All right. So a clockwise motion of a body will produce a clockwise torque, anti-clockwise movement will produce an anti-clockwise torque. Now conventionally we take a clockwise motion as a negative, and whereas an anti-clockwise motion as positive. Okay. Now clockwise torque along the axis is inwards. That means when you apply a clockwise torque, it moves inside. The torque is produced inwards, and when anti-clockwise torque along the axis is outwards. The best example for this would be a screw. Okay, so when you move the screw clockwise, the screw will go inwards. Okay, it will move inside, and when you apply an anti-clockwise motion, in that case the screw will move outwards. Okay, so you have to remove it, you will move it anti-clockwise, and if you have to fix it, you will move it clockwise. All right, so that's it. Thank you so much.